Our senses paint a picture of the world. We rely on them constantly. But what if I told you that this picture is incomplete? What if there's a hidden gap, a blind spot, right in the center of your vision? We navigate our lives unaware of this visual void. It's a fascinating quirk of our biology. Our brains work tirelessly to compensate, filling in the missing information. This isn't science fiction. This is the reality of the human visual system. Join me as we embark on a journey into the eye. We'll uncover the secrets of the blind spot. We'll explore how it works and why we rarely, if ever, notice it. Prepare to be amazed by the power and adaptability of the human brain. Imagine a world without sight. Our eyes are our windows to the world, capturing light and transmitting it to the brain. They are complex organs, intricately designed to process visual information. At the back of the eye lies the retina. This is where light is converted into electrical signals. These signals travel to the brain via the optic nerve.
The optic nerve acts like a data cable, carrying visual data to the brain for interpretation. Think of it as a high-speed internet connection for your eyes. But here's the catch. Where the optic nerve exits the eye, there are no light-sensitive cells. This creates a small gap in the retina, a blind spot. Every single human eye has one. It's a biological necessity, a trade-off for our ability to see.
The retina is a marvel of biological engineering. Imagine a delicate, light-sensitive wallpaper lining the inside of your eye. That's your retina, capturing the world around you in all its vibrant detail. It's packed with specialized cells called photoreceptors. These cells are responsible for converting light into electrical signals. The retina is like a living canvas, constantly being painted with light. Think of a digital camera sensor. Just like the sensor captures light to create an image, the retina does the same for our brains. But unlike a camera sensor, our retinas are constantly refreshing, sending a continuous stream of information to the brain. This allows us to perceive motion, depth, and the ever-changing nuances of the world around us. It's a truly remarkable process. There are two main types of photoreceptors, rods and cones. Rods are highly sensitive to light, allowing us to see in low-light conditions. They're responsible for our night vision and our ability to perceive shades of grey. Cones, on the other hand, are responsible for our color vision. Imagine walking through a moonlit forest. The rods in your eyes are hard at work, allowing you to see the shapes of trees and the path ahead. Now imagine that same forest bathed in the warm glow of sunrise. The cones take over, revealing the vibrant greens of leaves and the colorful plumage of birds. Together, rods and cones provide us with a rich and detailed visual experience. The optic nerve, a data superhighway. Now, let's trace the path of these electrical signals from the photoreceptors to the brain. This is where the optic nerve comes in. It's a thick bundle of nerve fibers like a data cable carrying vital information. The optic nerve emerges from the back of the eye, carrying millions of signals from the retina. Imagine a bustling highway, with cars representing the electrical signals. The optic nerve is like a high-speed, multi-lane highway, ensuring the rapid and efficient transmission of visual data to the brain. Without the optic nerve, our brains would be completely in the dark, unable to process the visual symphony of the world around us. The blind spot's strategic location. Here's where the blind spot comes into play. The optic nerve needs a way to exit the eye. At this exit point where the optic nerve fibers converge, there's no room for photoreceptors. This creates a small gap in the retina, a blind spot. It's a necessary trade-off for our ability to see. Think of it like a small hole in a tapestry. The tapestry is still beautiful and intricate, but there's a tiny gap where the threads come together. Similarly, the blind spot is a small but unavoidable consequence of the eye's design.
Our brains are incredibly adept at compensating for this gap. You might be wondering, if we have a blind spot in each eye, why aren't we constantly aware of these gaps in our vision?
The brain's remarkable trickery. Our brains are masters of deception, especially when it comes to vision. Think about it. We have a blind spot in each eye, a place where there are no photoreceptors to detect light. Yet we don't go around seeing black holes in our visual field. How is this possible?
The answer lies in the brain's remarkable ability to compensate. Instead of leaving a void in our perception, our brains seamlessly fill in the missing information. They do this by analyzing the surrounding visual cues and making educated guesses about what should be in the blind spot. It's like a skilled artist retouching a painting, using their knowledge of light, shadow, and texture to blend the missing area with the surrounding scene.
Filling in the gaps, perceptual completion.
This process of filling in missing visual information is called perceptual completion. It's a fundamental aspect of how our brains make sense of the world around us. Our brains strive for continuity and coherence in our visual experience. They don't like gaps or inconsistencies.
Think about looking at a tree partially obscured by a lamppost. You don't perceive the tree as two separate pieces. Instead, your brain seamlessly fills in the missing section, creating a complete and unified image of the tree. This is perceptual completion in action, constantly working behind the scenes to provide a smooth and uninterrupted visual experience. Binocular vision. Two eyes are better than one. Another reason we don't usually notice our blind spots is because we have two eyes. Each eye captures a slightly different view of the world, providing our brains with two separate images. This binocular vision is crucial for depth perception and spatial awareness. Think about holding your finger in front of your face and closing one eye at a time. Notice how your finger seems to jump slightly from side to side. This is because each eye sees a slightly offset image. The brain combines these two images, creating a three-dimensional representation of the world. The power of unconscious processing.
Here's the most amazing part, Dad. This entire process of compensating for the blind spot happens unconsciously. We don't have to think about it or make any effort to fill in the missing information. Our brains are constantly working behind the scenes, seamlessly weaving together a complete and coherent visual experience.
Think about all the other unconscious processes that our brains handle effortlessly. Breathing, heartbeat, digestion. Our visual system is no different. It's a testament to the incredible power and efficiency of the human brain. The illusion of a seamless visual world. Our visual experience feels complete and uninterrupted. We look at the world and it seems like we see everything in front of us without any gaps or holes. This illusion of a seamless visual world is a testament to the brain's remarkable ability to compensate for the blind spot. Think of a movie projector. It flashes a series of still images in rapid succession, creating the illusion of motion. Similarly, our brains take the incomplete information from our eyes and construct a smooth, continuous visual experience. We don't perceive the world as a series of disjointed images with holes in them. Instead, we experience a fluid, dynamic visual landscape. How does the brain fill in the missing information caused by the blind spot? It relies on context.
The brain uses the surrounding visual cues, patterns, and our past experiences to make intelligent guesses about what should be in the blind spot. This process is remarkably accurate most of the time. Imagine looking at a straight line partially obscured by a coffee cup. Your brain doesn't see two separate line segments. Instead, it infers that the line continues behind the cup, creating a complete and continuous perception of a single straight line. This is the brain's contextual filling-in process at work.
The spotlight of consciousness. Another reason we rarely notice the blind spot is because our attention is selective. We can't focus on everything in our visual field at once. Our attention acts like a spotlight, illuminating the things we are directly looking at while leaving the periphery less detailed. Think about reading a book. You are intensely focused on the words on the page, while the objects in your peripheral vision fade into the background. Similarly, our brains prioritize the information in the center of our gaze, where visual acuity is highest, and pay less attention to the peripheral regions where the blind spot resides. The blind spot, a testament to brain's adaptability.
The blind spot is not a flaw in our visual system. Instead, it's a fascinating example of the brain's remarkable ability to adapt and compensate. Our brains have evolved to seamlessly work around this anatomical quirk, providing us with a rich and uninterrupted visual experience.
The blind spot teaches us that our perception of the world is not a passive reception of information, but an active construction by the brain. Our brains are constantly interpreting, analyzing, and even manipulating the sensory data they receive, shaping our reality in ways we often take for granted. Unveiling the blind spot, a simple test.
You might be wondering, if I have a blind spot, why haven't I noticed it before? It's because our brains are incredibly adept at concealing it. But with a simple experiment, we can bring this hidden gap in our vision to light. Find a blank piece of paper and a pen. On the left side of the paper, draw a small dot, and on the right side, draw a small plus sign, about 6 inches apart.
Now close your right eye and hold the paper at arm's length, focusing your left eye on the plus sign. Slowly move the paper closer to your face, keeping your gaze fixed on the plus sign. At a certain distance, the dot will disappear from your vision. This is your blind spot in action, the disappearing act. How your brain fills the void. As you continue moving the paper closer, the dot reappears. Notice how the area where the dot disappeared doesn't appear as a black hole or a blank space. Instead, your brain fills in the missing information, often with the white background of the paper.
This demonstrates the brain's remarkable ability to create a seamless visual experience, even with incomplete information. This experiment highlights the active role of the brain in perception. We don't passively receive visual information. We actively construct our visual reality. The brain constantly makes educated guesses about the world around us, filling in gaps and inconsistencies to create a coherent and meaningful picture.
Exploring the boundaries. Mapping your blind spot. You can even map the shape and size of your blind spot. Repeat the experiment, this time moving the paper slowly up and down or in a circular motion while keeping your gaze fixed on the plus sign.
Notice how the dot disappears and reappears at different points, revealing the boundaries of your blind spot. The blind spot is not a fixed point. Its location varies slightly between individuals and even between your own eyes. This is because of subtle anatomical differences in the position of the optic nerve head, where it exits the retina. By exploring these variations, we gain a deeper appreciation for the individuality of our visual systems.
The blind spot in everyday life. While the blind spot is easily demonstrated with simple experiments, we rarely notice it in our daily lives. Our brains are constantly compensating, using contextual cues and our two eyes to fill in the missing information. However, there are situations where the blind spot can have real-world implications.
For example, when driving, it's crucial to be aware of your blind spots. Adjust your mirrors properly and perform head checks before changing lanes to ensure that you are not overlooking a vehicle, motorcycle, or cyclist hidden from your direct line of sight. The blind spot is a reminder that our perception, while generally reliable, is not always perfect.
The wonders of vision. Our journey into the blind spot has revealed the incredible power and adaptability of the human brain. We've learned that our perception of the world is not a passive reception of information, but an active construction, a collaboration between our eyes and our brains.
The blind spot, far from being a flaw, is a testament to this remarkable partnership. It highlights the brain's ability to compensate, to fill in gaps, and to create a seamless visual experience despite the limitations of our biology. So, the next time you look at the world around you, take a moment to appreciate the intricate dance of light, biology, and perception that allows you to see.
Remember that what you see is not just a reflection of the world, but a creation of your own mind. And if you're curious to learn more about the wonders of the human brain and the universe we inhabit, be sure to subscribe to this channel for more mind-expanding explorations.